Yeah. So the first of the four topics that we will discuss today is the hypothesis test. So as the name suggests, this is some hypothesis that we are coming up with. And what is the state of the art is called the null hypothesis. And something that is contesting the state of the art or business as usual is called the alternate hypothesis. So the question is, are you going to accept or reject the H0 or H1? There are uncertainties that are associated with the data that you compute. What is the confidence that is associated with the numbers that we are looking at? The typical confidence level that we look at is 95% or 99%. 95% says that 0.05 variation from the normal status, which is again the claim that we are making, is significant. If it's 99%, then it's 0.01. So it is left to the user to choose this confidence. This is a Gaussian distribution that we are talking about. So this Z alpha comes from the value that alpha equal to 0.1, right? So now the Z alpha sort of like can be is decided based on whether you take your alpha, which is a confidence level, to be 99% or 95%, right? So now, since your Z is 0.4, we are not in the rejection region. So we fail to reject the H0.
Okay, so in marketing scenario, when we do a test, like you group two different, you group audiences into two different groups and consider one as test and control. And when you treat the test group with a specific type of ad set and you want to know whatever results that you're seeing is statistically significant or not, for this reason, you can use hypothesis testing concept.
So the next one is about the difference in difference approach. In the marketing analytics sense, when we are trying to talk about counterfactual prediction.
According to difference in difference, what we usually first do is calculate the percentage difference or percentage change between the control conversions in the reference versus test periods. The difference between this counterfactual value and the actual test period conversions in the test markets is going to be our lifted conversions. The lifted conversions divided by our predicted test conversions would be the percentage lift. Yeah, let's move on to the quiz. For the given geo-test data, which of the following is the correct percent lift? We have 5 correct answers.
DTW stands for dynamic time warping. So when we conduct these design of experiments, we need to choose time strands for the test and time strands for control so that we can compare, we can measure the incremental. We compare two different time frames. The DTW is one of the widely used approach because it can compare two different frequencies.
So in this example, actually we have test period data. Okay, let me introduce how we use it in GeoTest. So how do we identify this reference period? That we can, that is where we use DTW. So for identifying this reference period, we can like the time series data in the test period and find out the similarity score or the DTW score with different time series data. Windows, right? So time series windows in the data set and find out the score for them. The smallest score will be the most closest match to that of the data set in question. So that's how we can interpret the results of a DTW algorithm.